Next speaker is Kartik Selvarajan, who is a full stack tester. Today he will tell us the story of Medidata Solutions automation journey using robot framework. Please welcome to the stage Kartik. Okay. Fun.
Thank you, guys. Thank you for having me here. I am Kartik. I'm going to take a few minutes to just talk about myself and the company I work for. So I am a staff automation architect at Medidata Solutions. We are the leading clinical trials management software creators in the world. So how many of you know what clinical trials are? I'm pretty sure everyone does right now, COVID times and all that. So what most of you may not know is clinical trials is a very lengthy process. It takes anywhere between 10 years to 25 years for a drug to get approved. So whatever happened in COVID times is an exceptional approval, not a full approval. It's an emergency use approval and things like that. So there's a lot of data collection that goes through it and things like that. So we have about 19 of the 20 top pharmaceutical companies as clients, and through these clients we help service about 1.5 million platform users and about 7 million plus trial participants. Some more fun facts just to get you guys to know what the industry is and how much of an impact we make there. We basically, 2 of the 3 new innovative drugs are developed on our platform. Till date, we have about 26,000 clinical trials. We started about 22, 23 years ago, and we have about 26,000 clinical trials. And on any given time, we have about 3,000 active trials running on our platform. In the last year alone, we have had about 1,100 new trials, and our business has been just growing, which I will get into in the next few slides. And the really big metric which really surprised me was that about 70% of humanity has been touched by the work we do on our software. All right, so let's get into the meat of the talk today. So how was our automation, or actually how was life before we got onto this whole new automation journey using robot framework? So as I mentioned, we are a software as a service company, so we are in the cloud. We have microservices deployed. From a testing standpoint, our microservices our testing was primarily just manual exploratory. So manual testers working on new features and new enhancements, testing just specifically that. We do have automation for regression and all that, but that was primarily created by the engineers, so in the form of unit tests, acceptance tests. So the tester's responsibility was just pure manual testing. But we did have some motivated testers who wanted to automate some of their repetitive tasks such as when you deploy to a new environment, you do some manual smoke testing, sanity tests, and things like that, which is kind of repetitive and boring, right? So some testers decided to automate that. So some of them, maybe chose Ruby scripts. We are a predominantly Ruby on Rails heavy company, so some of them wrote Ruby scripts to do their automation. Some others, created their own Ruby-based automation framework using Selenium to do the automation, and some basically just use Postman scripts if they were backend services to do all that. So this automation, it was basically happening in silos. There was no reusability. Teams were working by themselves. Though it was doing its job, things were working fine. But as we grew and as we scaled, we realized that it was important that we had to collaborate with each other. And in order to collaborate, we had to make some decisions. We had to really unify the various automation solutions we had and come up with a common solution so that we could basically improve collaboration between the team members itself and increase reusability of whatever code we are writing. Most of the issues that we noticed that were happening were because of the failure point was basically during integrations. An application X talking to application Y, the integration basically not working after a new release was deployed, or the integration was slow and things like that. So each of these teams basically, whenever there was a new change being made, they were basically not able to update automation code because they probably did not know about that new change that was coming in and things like that. So if all of this was in a common framework, it would have been easy because you were basically reusing someone's code who was basically owning the core functionality, right? So we decided that we should create a unified. Oh, sorry, was I pressing the wrong button all this time? So we decided to unify this, and we created this whole unified automation solution. While we were doing that, we wanted to pick a tool which was going to be used all across our organization. So we had a couple of solutions. We had a Ruby-based automation framework, which we had already created. It was kind of dormant for a few years, but we wanted to revive that. We had some automation being done in Cypress, but Cypress was good for UI, not so much for APIs. So, and then one of our teams in the UK, they presented us with the idea of using robot framework. So we evaluated all the options we had, and we just we had a clear winner because that's why we are here. I'm here today. So why did we pick robot framework? Thank you. So why did we really pick robot framework, right? So we had, as I mentioned earlier, we had a manual testing workforce. Some automation, was being done by some few testers, but though our talent was technical enough, they did not have really strong programming skills. I mean, they were good, decent programmers, but not really good programmers. So we wanted something that was easy for our testers to onboard and basically give them enough time to scale up and upskill, right? So Robot Framework basically provided just that. It was easy, simple enough for someone with no programming skills to write automation, yet it was powerful and flexible enough for anyone with advanced or for power users to basically automate and get along their automation journey. So this was really the beginning of our entire Robot Framework automation journey. So while we were all excited to get on board and start collaborating and working on this, life changed, right? COVID happened, the world stopped. But for us, life really didn't stop. We just had to keep going on. Like I said, we are a clinical trials management company, so we just got more work in that period. So unlike everybody else, where you guys didn't know whether your offices were going to be working, we just had to work because we knew we were going to get more work. So our mission of just powering smarter treatments became even more important to us, and I think each and every employee in our company just started working even more harder because for us that mission was more relevant right now. So what we really did was in that period we noticed that because most of the pharmaceutical companies were creating new clinical trials for all their new vaccine attempts that they were doing, we were having more and more traffic flowing into our system. So our traffic volume spiked. Because they spiked, we had to, most of our teams were releasing performance, enhancements or scalability enhancements and things like that. So we were just churning out more and more releases every week or every month. So as we were releasing more releases, there was obviously more testing. So there was a need for us to actually consolidate our efforts and do some more automation so we can basically focus on the core feature that we're releasing and let the automation do its job of doing the regression testing and things like that. So what we noticed in this period was there were still some issues that we were noticing. These were issues because of some weird data shapes or maybe because of some kind of race condition in the system. But we decided that these could be probably automated, and that's when we decided that we need to probably execute these tests more in number and more frequently, so we could catch these issues earlier. So we have about 4 test environments, and we were surprised that we weren't able to catch some of these issues in all those lower test environments, and it had to go all the way to production. And then we realized that things were not going wrong, and then we had to roll back. So it was the only thing that we were really missing was we didn't have frequent automated tests that we were running. So one of our real needs was that we should be able to write a lot of automation code, and we should also be able to execute these automations more frequently to give us timely feedback. And that's what we did. So that was the beginning of our Robot framework adoption. So luckily, we had already started on our groundwork on starting our Robot framework automation. So we started off with 2 teams initially. We contributed to a common repository, added all our tests there. And then once we had some sort of a stable structure, a stable way of working as multiple teams, then we decided to onboard more teams. So slowly, from about 2 teams, we grew to about 6 teams using Robot framework, and ever since we've just kept growing. So currently, we support about 25 teams across our organization on one common repository, which houses most of our test automation effort. So moving ahead, I wanted to spend a little more time on how did we really implement this, right? What did our architecture look like? So of course, we decided to use Robot framework. So that's kind of the core of our framework. The first team that implemented this whole automation was a backend service. So we had to first start with APIs. So the need was automate the API test. So obviously, we are microservice architecture, which uses REST APIs. So we had to use some kind of a library to make those HTTP calls. Lucky for us, we had the Robot framework request library available. So we used that. We created a wrapper around the Robot framework request library. So this is something that we do across all our libraries. We try to create wrappers around them so that it is easy for us to flip those libraries around as they improve, or they there's a new or better version that comes out, so we can just plug the new version in and get rid of the old version, rather than having to change about 15, 20, or 100 files where those libraries are used individually. So we don't really encourage teams using the library directly in their test. We would rather emphasize on using the wrapper classes, so that way it's easy to maintain. So while we were doing that, we realized that we also needed some ways to operate on JSON. So we used the JSON library. And then we hit a roadblock. So we have our own custom authentication module. It's completely different. It's not any industry. It's our own inbuilt proprietary authentication system. So we had to figure out a way to authenticate that. So we wrote some custom Python functions to be able to do that. That would then basically, we wrapped all that together into another API helper class. And then once we had that core API helper library, which could make those HTTP requests across our systems using all the authentication protocols, we then bundled all that together into what we called as API resource helper files. So this API resource file was basically the key that was going to help solve the reusability problem. So these API resource files are basically, there's one file for every API resource or endpoint that we support. And it's built in such a way that any team can import this and use the methods or keywords inside it to make API calls around that resource. The main ownership of this resource file resides on the team or on those testers who work on the team which serve that resource. So if I was working on a team which serves on a resource X, all resource files related to resource X will be maintained by me because I'm the tester on that team. So that way, whenever there is a new change or enhancement made to that API, I contribute to that file and make those changes so that those changes reflect automatically into everybody else who is using that particular resource in their test. And then we plug them all together into our API test. We needed a test data file. And then we slowly realized that we also have to randomize test data sometimes. In fact, most of the times you want to do that because you don't want to create the same data again. Your applications are probably going to fail. So we needed some utilities to randomize data, so we created some common utils around some other robot framework libraries, which allowed us to do that. And then we basically had our entire API framework that was ready to go. So this was pretty successful. We felt very confident about what we had achieved, and this was really getting everyone excited. Obviously, the next step was to enhance this and to include some UI automation as well. So we created UI test, similar methodology. We needed a way to communicate to our browser, so we used the Selenium library to do that. We wrapped it up again in our browser util, and then we created another wrapper around the browser util to do some logging and so capturing some other metrics that may be required for logs, and created a wrapper around that called the UI helper. And then we decided, so while we did that, we knew we always, so we wanted to have a way in which reusability was always the top of our mind, right? So we wanted to be able to reuse code, and also our structure should be in such a way that it's highly maintainable. And one of the things we had learned from all our previous automation experiences was the page object model pattern for UI automation works really well. For maintainability and for readability, so we decided to do that. So what we did was we created page objects files for all the UI pages that a particular test interacted with. Once we did that, as you guys, if you're familiar with the page object model pattern, you basically have a file which has all the elements a user can interact with, and all the actions that he can do on the page, right? So we had to have multiple such files for every page that we had or that we wanted to automate. But a user does more than that, right? He interacts with multiple pages when he's trying to do a test. And some of these interactions are, again, reusable. So again, keeping that reusability aspect in mind, we then bundled some of those actions together, and we created what we called as a step definitions helper file. So this is something that, if you're familiar with Cucumber, this is something how Cucumber works as well. They have step definition files which allow you to do some common steps, and then you can use them in your test. So we tried to follow that approach, and again, we then put all that together into our UI test, and we had our entire framework. So this is pretty much how our architecture looks right now. It works pretty well, and most teams, are pretty happy with what we have done, and that's I think one of the reasons why we grew to about 25 teams in our organization, and we just keep growing. Every month there's a new team which comes and who wants to join our automation. So some teams actually have their own separate repos, but then they realize that they're spending too much time trying to do some work which has already been done by someone in this framework. So they just port over. So we have multiple repositories in organization which still use robot framework, but they have a separate repository. So they just port over to us, move only the tests and other reusable files, and the things still work. So while we did that, we were thinking about what more can we do. Obviously, these tests are good, but as of now, they're still running on our local machines. Right? So every time a user, tester wants to execute some tests, he's executing them on his local machine. So what we wanted to do next was we wanted to automate this process, take it to the next level. So what we wanted to really do was to achieve continuous testing. How can I run these tests on multiple test environments frequently in a more timely manner so that I can get faster feedback? So what we did was we created something called testing pipelines. So before we get into testing pipelines, I want to talk a little bit about our deployment pipeline and how that looks. So for deployments, what we use is a tool called GoCD. It's a CI/CD tool by ThoughtWorks. Our deployment pipeline, the way we have set it up in our organization is we have a build stage, a release stage, a deploy stage, and a test stage. It's pretty self-explanatory. I don't want to get into the details of it. But what happens at the part of the test stage right now is we run basic smoke tests. We could actually plug in our functional tests here too, but the issue there would be that these tests would just run once basically just during their application deployment, right? But we wanted them to run more frequently. So what we did was create separate pipelines having just a single stage, which was the test stage. And we just didn't create one test pipeline per environment, but we basically created multiple test environments, each doing, multiple test pipelines, each doing its own specialized test. So we had a pipeline for sanity tests, we had a pipeline for integration tests, we had a pipeline for regression tests, and we kind of played around with the orchestration so that we could extract the maximum value out of them. So how did we really orchestrate this, right? So we had our pipelines, a sanity pipeline, integration testing pipeline, regression testing pipeline. The easiest way to automate this was put this on a cron schedule, right? So we had a cron job triggering these pipelines. We picked up a time in the day where we felt that there was good traffic in our systems, because we don't want to run our tests when there is no traffic. It probably will just pass all the time, right? So we want to run our tests at a time where there is decent amount of traffic in our lower test environments, so that there is some usage, and then make sure that our tests pass. And obviously, we just spoke about the other kind of triggers that these had. So they also run after the application's deployment pipeline as well. So a deployment pipeline, once successful, will trigger off your test pipelines as well, and still give you timely information about how your system is performing. Another important thing that we did here was, as I mentioned earlier, we noticed that some of the key issues that we were facing was integrations with other applications, right? So we are a microservice architecture. There is a lot of communications between one service to another service, and each of them have their own deployment windows. So how did we communicate? So we noticed that these tests, so we were getting some issues in these communication channels. So we decided that it was important to have our integration tests run even more frequently than this. And how could we do that? Is we then triggered those pipelines, triggered our integration test pipeline whenever there was an application, a consumer application deployment happening. So every consumer who my application consumes, and every consumer who consumes my applications, basically upstream and downstream consumers. So we basically tied our integration testing pipeline to the deployment pipelines of those applications, and that way we got even more timely feedback. So what's next? So all this was giving us good feedback. Things were working fine, but again, software keeps changing, keep upgrading. There's new information coming in. So as new requests came in from all these teams who are using us, we realized that we could make this architecture better. So in the next few months, this is some things that we want to keep in mind. So one of the key things that we want to do is decentralize this. So currently what we have is all these teams collaborating and contributing to one giant test repository. And as you guys know, the reason why the world moved from monolithic architecture to microservices architecture is because it's easy to maintain, right? And what we are essentially doing now is creating another big monolith test repository. So we knew this is going to become a problem at some point, so we wanted to find a way to resolve that. So what we really did was, or what we want to do is, we want to actually move the individual application tests to their application code base itself. And so each team will then basically pull their tests out of that big monolith, move it to their application repositories, and eventually use the core framework as a library. So this core framework is not just robot framework. It's basically robot framework and all the other ancillary stuff we built to support all the operations in our organization. So all the reusable stuff we want to just combine together, create that as a reusable library, and then the tests alone will be ripped out, moved into application repositories, and then they will use this library. Another key thing that we are working on is something that is going to help our business users and senior management. We realized that the robot framework report that is generated is very verbose. It takes a lot of there's a lot of information in it, which is sometimes not necessary for business users and others, right? So we try to get some of their requirements, and we created a custom reporting utility which reads the output.xml file and generates a report that is easy to read for business users and senior management. The next step, something that we want to do right now, is also create some intelligent dashboards. So we want to send some of this reporting data that we generate out of each of our test runs. We want to send it to a log aggregation platform. So the log aggregation platform we use in our company is called Sumo Logic, and we eventually want to use that data in Sumo Logic to create some dashboards in Sumo Logic that we can senior management or even us as testers can see to see the trend of our historical test runs and things like that. And that's what we are right now, and that's pretty much the end of the talk. I want to just give a few shout-outs. Thank you to the Robot Framework Foundation for all the amazing work that you guys do. We certainly have benefited a great deal out of this, and looking forward to working with you guys. I also wanted to give a shout out to some of my teammates. So Rama, Prakash, Shyam, Alan, Robert, if you guys are listening, thank you for all the work you guys do. Thank you.
Thank you, Karthik, for the excellent talk. There you go. Initially, when you switched to Robot Framework, did you experience any pushback from the team?
Surprisingly, no. Actually, yeah.
And do you miss Ruby?
I mean, so we don't miss Ruby because when I first came to the company, I did not come from a Ruby background. I learned Ruby, so I'm just in general open to learning any new language. So, yeah.
That's the spirit. That's the spirit. We have a bunch of questions. We have little time, but let's see.
Sure.
It looks like there are quite many teams and components involved in your testing architecture. Do you organize your test repository for such big system?
So we use GitHub. GitHub allows us to, we review our code pretty well. We have some practices, good practices that we try to enforce in all the PRs. In general, we have a good community of folks who contribute to reviews in GitHub. So I think that just helps maintaining a decent structure of our repo. I won't say it's great. There's a lot of improvement, and that's one of the reasons why we want to decentralize it so that the review process can also be easier. So that way, most of those reviews which are on the test sides of things can happen by the SMEs on the testing team, and the framework side of things remains within the core framework.
Okay, good. Which you prefer, library or user keywords, and how do you distribute your keywords?
So, like I said, we do not encourage using library keywords directly in tests. We try to wrap them up into multiple other layers of user keywords, and so yes, I prefer user keywords over library keywords. Yeah.
What kind of test data are you using, and what kind of data amounts are we talking about?
We don't do a lot of volume-based testing. We don't even do much of performance-related testing as well. I think the data we store data very simply in just YAML files. We have a unique set of data for every test, and we try to randomize the data as we can. So what we do in these test data files is just create a sample template, and then we append that with some random generated string or something like that, so that the data when created is kind of unique every time.
Okay.
So that's the kind of pattern we like to follow.
Excellent, excellent. Yeah. Hey, if you want to talk with Karthik, find him from the speaker corner. Thank you, Karthik, for the excellent talk.
Thank you, guys.